Sairam students, I welcome all of you once again to the third part of lesson number 15, Fun with the Magnets. So let's recall once again whatever so far we have learnt in this chapter. So students, in the last lecture we spoke about the uses of the different types of the magnet. So you all know that the magnets comes into the different shape, cylinder shape, bar magnet, cylindrical magnet, etc. So you can see that over here, when a magnet attracts an object, the object is displaced due to the magnetic force. So the magnetic force is involved. So the magnetic force is involved in the places like the factories, the ports, garbage deposits. The large objects are shifted from one place to the another place just because of the use of the magnet, right? So again students, one most important thing is that the magnets are also used in the cranes and work is done with the help of the magnetic force. So this shows that magnetism, it is a kind of the energy, right? So students, we also spoke about the properties of the magnet in the last lecture. So in the last lecture we discussed about few properties of the magnet. So let's learn one of them once again. So as you can see that students, the one of the property of the magnet that when we put the magnet into a steady place, a magnet always settles in the north and south direction. So as you can see that when we tie a magnet to a stand, it will always get steady in the north and south direction. Okay. And again students, you all know that if the magnet is directed towards the north pole, then it is called as a north pole. And if the direction of the magnet it is toward the south, then it is called as what? South pole. So as you can see that the north pole is always indicated by the initial letter N and the south pole is always indicated by the initial letter S. So the north pole is indicated by capital N and the south pole is indicated by initial letter S. Okay. And the second property of the magnet which we have learnt in the last lecture, that is the magnetic force is concentrated at the two ends or the poles of the magnet. So in the middle portion, the magnetic force is not much. The magnetic force is maximum at the north pole and the magnetic force is maximum at the south pole. So the poles, they are rich in the magnetic force. And again the next property of the magnet which we have learnt in the last lecture, as you can see that over here in the image, if we try to divide a magnet, like this, you can see that the two independent magnets are formed. So that means, can I say that we cannot separate the north pole and the south pole from each other? See, so if we try to divide a magnet, the two independent magnets are formed. That means the two poles of the magnets, they cannot be separated from each other, right? So students, this is the third property of the magnet. So what is the third property of the magnet? If a magnet is divided into two parts, the two independent magnets are formed. It means that the two poles of the magnet cannot be separated from each other. So now let's learn the fourth property of the magnet. So you can see that student, to see the next property of the magnet, what we are going to do, we have fixed a powerful bar magnet to a stand, and what we have done, we have fixed a iron bar at a short distance below the magnet. So that means what? We are using the two material in this case. We are using a bar magnet and the secondly we are using a iron bar. Okay, so can you see that over here? This is the magnet and below magnet we have placed a iron material, right? And what we have done, we have put the iron filings. So the iron filings, so you can see that over here. So we have attached a magnet on the top. Below magnet we have placed a iron bar, right? So what do you see here? So we can see that over here, the iron filings, when we have kept near to the iron bar, the iron filing got attracted toward the iron bar. Am I right? These iron filing, they did not stick to the magnet. They stick to the iron bar. But this iron bar, it is in contact with the magnet, right? So you can see that. So do one thing over here. After some time, take away the magnet. And then what will happen? When the magnet and the iron bar, when the iron bar, when they were in contact with each other, the iron filings, they stick to a iron bar. But when you, as soon as you take away the magnet from each other, you can see that you have took away the magnet away. Okay, so you took the magnet away from the iron bar, then can you see that over here the iron filings, they fall away. Okay, so that means what, students? Can I say that over here iron filings stick to the iron bar when the magnet is near to it. The iron filing will stick to the iron bar when the magnet and the iron bar, if they are in contact with each other. So if the magnet, it is in the contact with the magnet iron bar, then the magnet iron filing will stick here. But as soon as if you take away the magnet, they will fall off very immediately. Am I right? So can I say that the magnetism is induced in the iron bar? Right? So when you keep the iron bar and the magnet in contact with each other, magnetism is developed. But as soon as you take away a bar magnet and the iron bar from each other, so that time the magnetism vanishes. Right? So the magnetism is developed because of the magnet. So this is called as what? Induced magnetism. This is called as what? Induced magnetism. So can you see that over here? A magnetic material acquires magnetism when placed near a magnet. So any magnetic material like iron bar, nickel, cobalt, they will acquire magnetism if you keep that material towards a magnet. So this property or this property of the magnetism, it is called as what? Induced magnetism. So students, now the next property you see here, fix a bar magnet to a stand as shown in the figure. Okay, and let it become steady. Now take the another bar magnet near to the hanging magnet. So can you see that what we have done? We have placed the two bar magnet near to each other, right? And observe what will happen when we take the two iron magnet near to each other. So do the same thing again and again, exchange the end of the magnet, then what you will see? So students, when you take the magnet towards each other, you will notice that the like poles, you can see this is the south pole and this is the south pole. The same poles, they will not attract toward each other. If you bring the same pole of the magnet towards each other, they will fall apart. So can I say that the same pole of the magnet, they are not attracted, they are repulsive in nature. But suppose if we try to bring together the north and the south pole, can you see here? If we try to bring near to each other north and the south pole, they will get attracted toward each other. So can I say that the opposite poles of the magnet, they attract each other? Whereas in this case, the same poles of the magnet, if we try to bring them towards each other, they will repel. Right? So can I say that the repulsion occurs between the like poles of the magnet? The repulsion occurs between the like poles of the magnet, whereas I can say that the attraction occurs between the opposite poles of the magnet. So you can see that the repulsion is occurring between the same poles and the attraction is occurring between the different poles. So this is then one of the property of the magnet, right? So students, now the last property of the magnet we are going to learn over here. Suppose if we take a needle or a nail, place it steady on the table, keep on rubbing a magnet over it from one end to the another end. Do this 7 to 8 times. What you have to do? You have to take a needle and on the needle you have to keep on rubbing a magnet continuously. Okay. Then do one thing. Now take the few pins near to that needle. Okay, now what you will see? You can see that when you take the needle which is rubbed against the magnet, when you take the needle which is rubbed against the magnet and if you take this near to the pins will get attracted towards this needle portion. Why this will happen? Because the magnetic object acquires the magnetism. I just told you that magnetic material acquires the magnetism and this magnetism, it is the temporary and it lasts only for the short while, right? So you can see that over here we try to rub the magnet over magnetic material. So when we try to rub the magnet on the magnetic material, magnetic property got transferred to this needle. So when magnetic property transferred to the needle, the iron material gets attracted toward this because of the property of what? Magnetism. Are you getting my point, students, over here? So that means what? The magnetism property is also used in the electrical current also. Okay. So suppose student, if magnetism is produced in a nail due to the electric current. So this magnetism property we are using in the electric current also. So when it put it off, the magnetism will vanish. So if we try to produce the magnetism with the help of the electric current, then it is called as what? Electromagnet. What we call it as electromagnet. The magnetism is also the temporary. So can you see here? This is the iron material. So around the iron material, we are trying to provide the electricity. So if we provide the electricity to the iron material, the electromagnet force will be created, right? And do you know that this electromagnetism, it is used in many ways in our day-to-day life. So electromagnetism, it is used in our day-to-day life in the huge amount. Can you see here, students? This electromagnetism property, it is used in the CT scan machine. This is a CT scan machine. Electromagnetism property, it is used in our smart mobile phone also. Electrical magnetic property, it is also used in the ATM card. Have you seen the strip which is present on the ATM card? This is because of the electromagnetism. Electromagnetism is also present in the bell. It is also used in the crane, etc. Right? So the electromagnetism property is used in the all the day-to-day life activity. For example, you can see that the instrument like doorbell and the crane, the pin holder, door of the cupboard, they all uses the permanent magnet, right? So now what do you mean by the permanent magnet? The permanent magnets are those magnets who are made with the mixture of nickel, cobalt and iron. What do you mean by permanent magnet? The permanent magnets are those magnets who are made from mixture of nickel, cobalt and iron. For example, the material alkeno. The material alnico, it is a mixture of aluminium, nickel and the cobalt. Al, it is took from the aluminium. Ni took from the nickel and Co, it took from the cobalt. Right? So this is the permanent magnet. And do you know that how exactly the magnetism has been destroyed? The magnetism is destroyed if we heat the magnet, if we throw the magnet, if we knock down the magnet, or if we break the magnet into the pieces. So all these activity, they destroy the magnet, and therefore we have to use the magnet and we have to store the magnet very, very carefully. So can you see that we have to avoid all this activity. We don't have to burn the magnet. We don't have to break the magnet. We don't have to throw the magnet. Otherwise, the magnetic property will be destroyed. And that's why, student, to protect the magnet, a soft iron is placed in the box where the magnet is kept. A soft iron, the bar of soft or pure iron, it protects the magnet. Who protects the magnet? Soft iron. Soft iron protects the magnet, and therefore such soft iron, it is called as what? Magnet keeper. Who is called as a magnet keeper? Soft iron. Can you see the magnet keeper? This is called as what? Magnet keeper. This is a soft iron. This soft iron, it is used to protect the magnetic property. Understood, student? So students, here we have completed the lesson fun with the magnets. I hope so, student, you must have understood the lesson thoroughly. So let's recall once again what we have learnt in this chapter. We have learned that, students, over here, what are the magnet material. So iron, nickel, cobalt are the magnetic metal who get easily attracted towards a magnet. And what do you mean by the magnetic material and non-magnetic material? That also we have learned. The material which get attracted toward the magnet, they are called as magnetic material, and the material who do not get attracted toward the magnet, they are called as what? Non-magnetic material. We also spoke about the properties of the magnet. You all know that the magnet will always settle down in north and south direction. The north side will always indicated by capital N, and the south side will always indicated by the capital letter S. And again, students, we have spoke about the next property. That is nothing but magnetism is concentrated near to the south pole and the north pole always. The magnetism is not concentrated in the central part. And most importantly, the poles of the magnet, they cannot be separated from each other. And today we also spoke about the induced magnetism. So when we provide the electricity, the electromagnetic property has been created, and this electromagnetic property we used in our day-to-day life. Like I told you, electromagnetism we used in the mobile phone, ATM card, CT scan machine, etc. Okay. So students, I hope so that you must have understood the lesson very well. Please students, complete the notes of this chapter, complete the notes, and see the video once again to know about the fun with the magnet once again. Bye bye. Take care.